All right, I'm going to turn this last bit off and turn it back on. I know we're way past the time already, but I just want to finish this out. There's a parameter called is sleeping allowed. I'll explain it and I'll come back to it. Physics is a very computationally expensive feature in any game engine or SDK. But one of the ways that a game engine can reduce this is allow the physics engine to stop running if it's not needed. And so that's called sleeping. So what can happen is, let's say you create a physics body and there are no forces acting on it, no gravity. You haven't touched it. It hasn't been hit by anything. What will normally occur in torque is, if you have a dynamic body like that, a body that is allowed to move, is it will be created, it will be what is termed awake, and the physics code will be running. It will be evaluating. It will say, do I need to move this? Is anything occurring? Has it been hit? Etc., etc. All these heavy-duty calculations. But if it's allowed to sleep, a few frames later, what will occur is the engine will say, you know, nothing has occurred with this physics body in the last few frames. So it's likely that nothing will occur in the next few frames. I'm going to stop evaluating this object. I'm not going to try to move it. I'm not going to see if it needs to be repositioned. It's basically just sitting there doing nothing. So I'm going to ignore it. Now this can get you into all kinds of trouble. However, it's mostly a good thing, because sleeping will be turned off immediately if a collision is sensed. So if you have a body A and a body B, body A is not moving, body B is moving. Eventually body A will go to sleep. I'm holding my hands up like you can see me. Body A will go to sleep. Body B moving, it's not sleeping. It's continuously being evaluated by the physics engine from frame to frame. And so as soon as body B gets close to body A, the physics engine will say body B is about to hit body A. And then it will also say, oh, wait a minute, body A is asleep. It needs to wake up again because I'm about to interact with it. It's about to get some action. And so by the time body B collides with body A, it will be awake again. Body A, will be awake again, and everything will function well. Now I said that sleeping can get you in trouble, and I will demonstrate how in a minute. But let's make the pivot arm first. So the pivot arm, which is not the right arm, let's just call it the pivot arm. This is what happens when you write demo code really fast and you copy and paste. You leave comments in that make no sense. So what I'm going to do first is I'm going to uncomment this bit. I'm going to get rid of all this code. There we go. And I'm going to show you how this function works, the create arm segment. Let's rerun this, reload it. Without looking at the code, what's occurred is we created our block like we did above, and we called that function create arm. And what it does is it creates this rounded rectangle with two dots which are welded to the end. They're using weld joints. So if this arm were to move around, these dots would move with it. Now the reason I did that was both to give me objects to reference as the position of a joint, but also to give you visual feedback. I would not suggest when you create your own games that you create little circles welded to the ends of the arms. Why? Because let's think about this. We got a head, torso, two leg segments, two more leg segments, two arm segments, two arm segments. These all have physics running on them. By adding additional bodies, here, 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 all these dots, those also have physics, and they also have weld joints. A weld joint costs you computation, because if the arm moves, the weld joint says, hey, move the hand, or the dot. Or if the dot moves, it says, move the arm. And it's attached to this. So now I got to evaluate that weld joint, and this weld joint, and that weld. It's a lot of extra computation. I did it in these examples purely to give me something easy to reference in my code, and to show you the body parts very clearly, so you could sort of see what's going on. In fact, if this becomes a popular topic, and if people give us good feedback on this, what I can do is provide a variation on this example, that does not have the weld points in it. So you can see what a proper looking doll looks like without the extra circles and the weld joints. Nonetheless, purely for feedback and ease of manipulation.
There's also a ragdoll example included in the sample code with Corona. So I don't, without looking at the code and comparing them to what you have there, that might be an option as well to go just look at the sample code.
That is actually good sample code.
Mm-hmm.
I'll tell you what the difference is. The difference is that whereas I draw my arms using one line of code, they draw their arms and their legs using several lines of code. And so I chose this way because even though it looks complicated, it's quite a bit simpler to read once you understand the format than what they did. And mine's a little more, I don't know, I feel like I can reposition the arm in less effort. It's a either or kind of thing.
Yeah.
Neither is better or worse. It's how people approach code. Okay, so this call here, I know we're on the clock here. I'll go quickly. We won't even really dig much into this. Basically what this is a function that takes a group. I'm going to tell it an X and a Y position, which is where I want to place the center of the arm. Everything is placed by the center. So I need to calculate, if I want to move it to the right, I got to say, how long is the arm going to be? It's going to be 50 pixels long. Move the X to the right. And then what that'll do is it'll place it by the center, but the center is now 50 pixels to the right. I tell it how long to make the arm segment, which is a variable that we've created above. I tell it how thick to make the arm segment, and I tell it how thick around the what the radius of the joint is. And it's going to take all of this, and in this piece of code, which I invite you to crawl through, it's going to set up another filter. I could just as well have created this globally. It's going to create a rounded rectangle with, this should be radius, but I set it to 12. Regardless, it's going to add a body to the segment. It's going to use the filter. It's going to set the density to 1. It's going to position it based on the rules that I gave it up here. It's going to set some damping, which we talked about. Then it's going to create a circle for the left side and a circle for the right side, and it's going to use a weld joint to stick it to the segment, to make it stick to it, so if this moves around, this moves, and vice versa. And then it's going to return the rectangle, the circle, the circle. And with this, then I can start to do assembly. So let's take a look at how I assemble it, and then I'll show you the sleeping bit, and we will be done with me talking for today. Comment that out. Comment that out. All right, so what I said here was I'm going to return a segment, a marker.
I don't think it commented anything.
Sir?
I don't think it commented anything.
Right. Thank you. There we are. All right. So the function is going to return a segment, a marker, and a marker. Let me make this bigger so you can read it. So I'm going to store these. You see I'm using commas. This is a Lua thing. Basically, it's returning 3 variables. So I say put the first one in here, the second one in here, and the third one in here. Okay, so I pass in the group, and then I say get the center position of the cube and add half of the length of the segment, which is the length of the arm thing that we're going to make, minus the radius. It's just a math equation. If you think about it, we're going to take off half the radius, or we're going to take off the radius, because the arm's going to be shorter by that amount. And then we want it to be aligned vertically with the cube. As you can see, we want it to be vertically with this, but we want to push the end all the way to the center. And then all I do is I create a pivot joint, and I attach the marker, which is really the wrong way to do it. Still works. I'll explain. Remember how, okay, I attach the marker. Now remember, the marker, the circle, is attached to the body. So what I've done is I've attached an arm to a marker and a marker to this. So it's a very complicated linkage. So when this executes, the code says, I got this connection, has it turned. Let's look at the next linkage, and the next linkage, and the next. You're creating this long chain of evaluations, and the more joints you have attached to each other, the more code has to execute every frame.
Right.
What would have been better...
But we're doing this for illustration purposes.
We're doing it for illustration purposes. What would have been better, and what I do in the doll code, is I mount the arm, the white part, instead. Slightly different, but much better in terms of execution speed.